Hello everyone. Today, we'll talk about a popular technology in data center network security field, microsegmentation. First, let's look at the background of segmentation. In the past, our security policy was based on the idea that the traffic generated in the data center is secure, while the traffic generated outside the data center is insecure. Therefore, the firewall needs to be deployed on the DCN boundary. North-south traffic flowing to the DCN is imported to the firewall for analysis to ensure that only authorized users can access internal resources of the DCN. Security analysis technology for traffic on border devices is also known as border security technology. Traditional border security technologies cannot defend against all complex third-party attacks. In addition, as the cloud data center develops and data storage and web applications increase, east-west traffic on the DCN increases continuously. In the data center, multiple zones are isolated and strong access control is required between applications, resulting in higher requirements for security management and control. On a next-generation DCN, we need to analyze all traffic based on the Zero Trust security policy and consider the internal security protection of the DCN. Can traditional border security technologies for analyzing north-south traffic be used to analyze east-west traffic on a DCN? The answer is no. This is because traditional border security technologies isolate network traffic mainly using subnet assignment and ACLs. However, these technologies have the following problems. First, VLAN IDs or VXLAN network identifiers can be used to divide subnets for service isolation, but servers in the same subnet cannot be isolated. When different subnets share a gateway, servers in these subnets cannot be isolated because the gateway has routes to each subnet. Second, ACL rules can be configured to isolate servers. However, in a data center, a large number of ACL rules need to be deployed for a large number of servers, resulting in complex configuration and maintenance. In addition, ACL resources of network devices are limited and cannot meet customer requirements for deploying a large number of ACL rules. Last, virtualization technology makes it difficult to locate the secure border. If all traffic between VMs in the data center is imported to the firewall for analysis, it is difficult to meet the requirements of the data center for flexible, distributed, and scalable deployment. This may cause bottlenecks in performance and capacity expansion. Based on the preceding analysis, we can see that traditional technologies cannot meet the current requirements. We need to find a new technology to solve these problems. Now let's talk about this technology, microsegmentation. Microsegmentation can be literally divided into two parts, micro and segmentation. Segmentation means that a network is divided into several subnetworks according to different grouping rules. Different subnetworks are isolated from each other, and in this way, data packets can be transmitted only between agreed nodes. Micro is in contrast to physical network segmentation. Physical network segmentation is implemented based on VLANs or VNIs. The devices with different VLAN IDs or VNIs are isolated from each other, while the devices with the same VLAN IDs or VNIs can communicate with each other. Compared with physical network segmentation, microsegmentation is more fine-grained because it can divide subnets based on the IP addresses. That is, even the devices that belong to the same VLAN can be isolated from each other. For example, VM1, VM2, VM3, and VM4 belong to the same broadcast domain, VNI10. VM1 and VM3 belong to the same security zone, and VM2 and VM4 belong to the other security zone. When physical network segmentation is used, VM1 and VM4 can communicate with each other because they belong to the same broadcast domain. That is, the devices that belong to the same broadcast domain and different security zones can communicate with each other. When microsegmentation is used, VM1 and VM4, which are in the same broadcast domain, cannot communicate with each other because they belong to different security zones. That is, the devices that belong to the same broadcast domain but different security zones are isolated from each other. Microsegmentation provides more fine-grained grouping rules compared with VLANs or VNIs. It groups servers on the DCN based on specified rules and applies traffic control policies based on endpoint groups to isolate services between servers. Therefore, microsegmentation is also called EPG-based security isolation. CE series switches use the group-based policy model on the VXLAN network to implement microsegmentation. The GBP model consists of EPG and GBP. The EPG is a group allocated using the IP address-based grouping policy. An EPG can contain multiple servers. GBP is a traffic control policy based on the EPG, protocol number, and port number, which defines how to control the traffic between the members in an EPG or in different EPGs. After understanding the background and definition of microsegmentation, let's take a look at the deployment. In the cloud data center, microsegmentation services can be orchestrated through the cloud platform or the Agile Controller DCN. The cloud platform interconnection is generally used in the cloud network integration scenario of the Cloud Fabric DCN solution. In this scenario, first, the cloud platform is used as the microsegmentation management plane that is responsible for providing EPG information and GBP deployment. The cloud platform delivers related configuration information to the Agile Controller DCN through the RESTful API. Second, the Agile Controller DCN is used as the microsegmentation management plane that is responsible for service isolation and abstraction based on application groups. Last, the CE series switch is used as the microsegmentation data plane that is responsible for matching packets with EPG information and GBPs delivered by the Agile Controller DCN. Then the CE series switch determines how to process the packets. The automatic orchestration of the Agile Controller DCN is generally used in the network visualization scenario of the Cloud Fabric DCN solution. In this scenario, first, the Agile Controller DCN is used as the microsegmentation management plane that is responsible for providing the abstract orchestration model. The Agile Controller DCN delivers EPG information and GBPs configured on the GUI to a CE series switch through the netconf API between itself and the CE series switch. Second, the CE series switch is used as the microsegmentation data plane that is responsible for matching packets with EPG information and GBPs delivered by the Agile Controller DCN. Then the CE series switch determines how to process the packets. That's all for today's introduction. Thanks for watching. Next time, we will introduce the implementation of microsegmentation. See you then.